What's wrong? Yes. Okay. I'm just going to use QF for quadratic formula, okay? I don't want to have to write it out. So, yep, this is not in standard form. So the first thing we would want to do is 5x squared equals a negative 2x plus 3. We'd want to move all this over. And put that into standard form. Then we want to identify our A, B, and C. In this case, our A would equal 5. B would equal 2, and C would equal negative 3. Using the quadratic formula, we know x is equal the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to get x is equal to a negative 2 plus or minus the square root of 2 squared minus 4 times 5 times a negative 3. All of this over 2 times 5. So using my calculator, I'm going to do what's underneath the square root first. So 2 squared minus 4 times 5 times negative 3. So I get a negative 2 plus or minus the square root of 64. Square root of 64 is 8. And from here, I get my two possible solutions. So x would equal a negative 2 plus 8 over 10. That's 6 over 10, or 3/5. Or x would equal a negative 2 minus 8 over 10. That's a negative 10 over 10, or negative 1. Questions? All right. Let's try a couple more. Is it already in standard form? If it's already in standard form, just be able to identify your A, B, and C. So my A is equal to 4, B is a -3, C is 2. Quadratic formula. X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. You're going to sing this for the next 3 days. All right. So the opposite of a -3 is 3. Plus or minus the square root of a -3 squared minus 4 times 4 times 2. All over 2 times 4. Now, I'm going to use my calculator to figure out what's underneath the square root. -3 squared minus 4 times 4 times 2. Now, what happens with this square root of a -23? Why not, Summer? Remember? Good. The square root of a -23 is imaginary. So this one is no real solutions. In later math classes, you'll find the imaginary solutions, but you can't find the real solutions. Once we start dealing with imaginary numbers, there's some things you haven't studied yet. So you can't do this with real numbers. There are no real solutions. This is all because of the negative on that 23. Okay? All right. This is example 4, I guess. All right, so now we want to solve 3x squared minus 1 equals 5x using quadratic formula. Is it in standard form? Well, standard form is ax squared plus bx equals, or plus bx plus c equals 0. This one is not set equal to 0. In order to do that, I need to move the 5x over. So 3x squared minus 5x minus 1 is equal to 0. Then we'll find our a, B is a -5, and C is a -1. Quadratic formula says x is equal the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, the opposite of a -5, 5, plus or minus a -5 squared minus 4 times 3 times a -1. All of this over 2 times 3. I'm going to use my calculator to determine what's underneath the square root here. So -5 squared minus 4 times 3 times -1. I'm going to get the square root of 37 all over 6. Now, can we simplify the square root of 37? Not this time. So x would be 5 plus the square root of 37 all over 6, or 5 minus the square root of 37 all over 6. These guys would be our exact answers. If I plug it into my calculator and do 5 plus the square root of 37, all of the numerator, and then divide that by 6, I get approximately a 1.847. Or I do 5 minus square root of 37, find out what that is, and then divide it by 6. I get a negative 0.180. These are your answers to 3 places. Questions? Ryan, you doing all right with this? Okay, Summer? Okay. Austin, any questions from you? Okay. All right, so which method do you use? We've talked so far about 4 different methods of solving. The first one is factoring and the zero product property. An example of this one might be something like x squared plus 5x plus 6 is equal to 0. And we figure out which two numbers multiply to give us 6 and add to give us 5. And we do like an x squared plus 2x plus 3x plus 6 is equal to 0. Right? This is what your test was on. Then we know the mini equations, we'd have x plus 2 is equal to 0, or x plus 3 is equal to 0. So x is a negative 2, or x is a negative 3. We would use factoring and zero product property. When you can easily factor. Do you know how sometimes you can look at a trinomial and you already know what the answer is going to be? Or what the factors are going to be? This is a case where, this is a case where we would factor and use the zero product property. If I've got to dig a little bit, if factoring is hard, the only time I'm going to factor then is if they tell me I have to. Right? I want to use factoring and the zero product property when I can easily see the factors. Okay. Now, the second method that we want to talk about is the square root property. This is the fastest way to solve an equation when we have something like x squared minus 16 is equal to 0. And then what we did is we simply added 16 to both sides and then took the square root. So that our x would have to equal positive or negative 4. This one can only be used for something like ax squared is equal to c. Right? This doesn't work if I have a middle term. So this square root property method would not work if I had a trinomial. It really only works when you have technically the difference of squares. So it's limited in its methods. Okay? Third type. Third type is completing the square. This is what we did last week, Thursday. Completing the square looks something like, let's go through the whole thing. Let's do an x squared minus 8x is equal to, what do I want? Let's do 20. Let's do 24. Okay. So do you remember how to do this? X squared minus 8x, and we're going to add something to both sides. Do you remember what we're adding here? We're going to take this b term, so we're going to do negative 8. We're going to divide it by 2, and then we're going to square it. And what we add on the left side, we have to add on the right side. There we go. That this would be an x minus 4 squared is equal to 40. Now I can use part 2 to take the square root of both sides. I can add 4 to both sides. And this would be a plus or minus square root of 40. And then I just need to simplify 40. So 40 is 4 times 10. I can take the square root of 4. So there's my completing the square method. When do we use this? Well, really, honestly, when you have to. So you're going to have to do completing the square only when requested. Now, as you get into higher mathematics, if you have to take an intermediate algebra or college algebra class, we use completing the square quite often as a part of a larger problem. So it is a tool in your tool belt that is needed and necessary, but it's not one we reach for often. So depending on where you're going, like knowledge-wise, what you need to know, this may be one of those tools that you purchase but never really use. You know, sort of like in your house. I'm sure you've probably purchased and used a hammer. You've maybe used a screwdriver, but maybe not a wrench. You know, like you have a wrench, but you don't use it very often. That's kind of what completing the square is. Like when you need it, you have to know how to use it. But until then, eh. So we're going to test you on this skill, and then it's going to feel like you learned it for nothing until you need it. And then it's going to be, crap, how do I do that again? It's just the way this particular skill works. All right. And then the last one is the one we talked about today, and that's the quadratic formula. So let's say we've got an x squared. Well, let's do 4x. 4x squared minus 10x plus 9. A equals 4, B equals negative 10, C equals 9. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So here we have x is equal to a 10 plus or minus the square root of a negative 10 squared minus 4 times 9 all over 2 times 4. And I'm going to do the negative 10 squared minus 4 times 9. I thought so. And at this point, as I'm solving this, what should I recognize? Yeah, so what should that tell me? No. Not no solution, no. Yeah, no real solution. There is a solution, Summer. It's just imaginary numbers. So we have to say no real solution. Now, when do we use quadratic formula? Basically, anytime we can't see it to factor easily, we can use quadratic formula. Quadratic formula is our utility hammer. This is the one that we can use almost all the time. So for many students, it becomes their go-to. Like it's the one that they use consistently. However, it can get overused. So be sure, particularly when it comes time for the test, that you're using the requested method. So if it says use factoring, make sure to go ahead and show me the work with factoring. That kind of thing. Right? Okay. Questions?